Okay, let's have a look at this question here. Now, I've been asked why, and by the way, there are three equations here. There's one equation here, there's going to be one equation here, and there's another equation here. And we're told that the drain team actually has an equation for this line here. Well, the equation for that line there is 2d, so c is equal to 2d plus 15. And the question is, wait, where does the 15 come from? Okay, that's the question. It's a good question. I like it. And the answer can be found very simply if I was just to simply draw this line all the way back, because it's the equation is not for the whole line, because it's just for this part of the line. So from this part here, from 10 to 35, this is true. So really we should state this is true when, or where if you like, D, and I'm assuming this is the D, yeah, D is going to be greater or equal to 10 and less than or equal to 35, yeah? In other words, just from here to here. And you could just state that. You could say from 10 to 35, D, that's the equation of that line. The equation of this line, of course, is very different. This line is 35, and this is going to be a C equals 35. The equation of this line here is C is equal to 2D plus 15. And of course, the 15 comes from the fact that if this line was to continue here, the intercept would be C is equal to 15. In other words, if you made D equal to 0, in other words, D equals 0, C is 15. But let's find it another way. In other words, let's prove that it is in fact 15, because you can't see it. It doesn't exist here, because the line stops here and veers off over this way. Yeah. So let's prove that the intercept is 15. So I'm going to write Y just for now. Y. No, I'm going to use C and D. I won't use Y equals mx plus C. Typically, of course, it would be Y equals mx plus C, or C equals, I'm going to call it MD plus C. M is the gradient. Now, of course, M is rise over run. And rise, in this case, let's actually just look at this line here, and I'm going to actually create some more dots here. So let's see if we have some more dots here. Another dotted line. Here we go. So this line here is C equals 35. So the rise is going from this point here, which is at 35. But that's, by the way, it's 35 along as well. But it's 35, that's C equals 35. And at the top here, the value is 85. So the top value here, this line here is really C equals 85. This dotted line here, yeah? So we've got C equals 35 is this line here. C equals 85 is the line. It's the difference, of course, between 85 and 35. So I could actually go 85 minus 35 equals 50. So this distance here, from here to here, is in fact 50. So the rise is 50. All right, so what's the run? Well, the run's going from 10 to 35. In other words, 35 minus 10 is 25. So the distance from here to here is in fact 25. There it is. So that's going to be the run, 25. So of course 50 over 25 is 2. So now I can write this in again. This time I'm going to substitute something in. So I'm going to C is equal to 2, that's my M value, 2D plus C. Now let's find some C and D values. Well, here we've got heaps of these, yeah? This line, anywhere along this line we could use. So here's this 10, 35. This point here is 10, 35. There it is. So this is my X value, my D value, and it's my C value, my Y value. So let's put those in. So I've got a C value I need. My C value is 35. There it is. 35 is equal to 2 times D. What's my D value? 10. There it is, 10 plus C. Of course, 2 10s are 20, so 35 is equal to 20 plus C. And I'm just going to subtract 20 from both sides. There we are. Minus 20, minus 20. Gone. Then C is equal to 35 minus 20, which is 15. And there is the missing 15. That's where that, oh, I can't see that, sorry. That's where that 15 comes from, yeah? That's why it would continue there. Of course, you would never write that. So you would see this bit here. You use that formula when D is between 10 and 35, or you could write it as an inequality if you like. This is what we call the domain, by the way. And you should always include domain statements when you've got partial lines. Like this is not a continuous line, yeah? This line is continuous in this direction, but it definitely stops here, yeah? And this is not a continuous line either. This is a line segment. Starts here, ends here. And so for this one here, you could say C is 35, yeah? For this one here, you'd say, well, C is equal to 2D plus 15 when, and in this case, C is 35, and we can actually put a statement here. In fact, I'll do it over here. I'll put it up here. When D is between, D is from 0 to 10. Or you could say D is going to be like that, yeah? D is equal or less than 0, or equal or so on to 10. Of course, it can't be equal to 10 for both of these. So you might say this one here is going to be greater. So it's from 0 to 10 here for this line here, and for this line here, it's greater than 10. So you might even make this like cross out that bit there. D is going to be greater than 10, but I don't think they're going to worry about the detail there. But nonetheless, that's what I would do. And that is, anyway, in case of the answer there, where the C equals 15 comes from. Hope that makes sense.